Okay, let's take a look at this first question. It says, you owe the bank $3,048, and you must make equal monthly payments for the next 2 years. And how much do you have to pay each month? Okay, so you owe the bank $3,048, and you want to pay it back in 2 years in equal monthly payments. Okay, so if you have 2 years, that means you have 24 months to pay this off, right? And you want to know how much you have to pay each month. Well, now that means we're separating this into equal monthly payments or equal amounts. When you separate into equal amounts, that is called division. So we need to divide. So here we need to take 3,048 and divide it by 24. And I had to change to months because I want to make monthly payments. So separating into equal quantities is division. So that's how we know we have to divide here. Now, before we even do this problem, there's so much we want to learn first. Okay? One thing is just even how you would express division. This is one way. A lot of people go, I don't know what number goes on the outside. Well, think about this. 3,000, now this is really strange. Just think about this. Consider thinking about this. 3,048 divided by 24. Divided by 24. Think of by, so the 24 is on the outside because it's going by. You're dividing by 24. Okay, so the 24 goes on the outside. That's one way to write it. Another way to write it is 3,048 divided by 24. Another way to write it is 3,048 with that line, like almost a fraction line, divided by 24. And then sometimes they have a fraction line that looks like almost a slash, looks like that. Okay. In order to do the problem, we really want it written in that way. But in algebra, that's the way we really want. We don't really like this in algebra, this little division symbol, okay, because it doesn't really help us sometimes take words and put it into symbols because sometimes it's harder to use. So this is really what we like in algebra, but this is what we like when we're actually going to do the problem. Okay, but we're not going to do the problem yet. We're going to come back to this problem. So just keep that problem in mind as we kind of go on. All right. When I look at this, I want to talk about the parts of this problem. What you're dividing by is called the divisor. That's what you're dividing by. What you're dividing into is called the dividend. And your answer, which you usually put up here, the answer is called the quotient. To be honest, I'm not going to use these words very often. You don't really see them very often in algebra. You see them in arithmetic, but not in algebra. But that's a big one. You have to know quotient means division, just like product means times and sum means to add. Okay, so you have to be familiar with that word. That will be important. Let's look at some keywords for division now, because we're going to have to know how to express words into symbols. So let's take a look at the following. And these words are in the workbook. Okay? These are key words or phrases for division. Okay, so we're going to put the words or phrases there. Then we have an example. Then for the symbol, we're going to do this a little differently because I'm going to do it exactly the way it is in your workbook. So the key word or phrase is divide, obviously. That's one key word. Divide means to divide. That's amazing. Okay, so I could say divide 3,048 by 24. Let me make that a better line for you. Okay, another key word is quotient. The quotient of $3,048 and 24. Now notice the and again does not mean to add. Quotient tells me to divide. That's where the division symbol goes. I'm probably going to use the line, the fraction line for the division symbol. Okay? And divided by is another key word or phrase. Divided by, so I would have 3,048 divided by 24. Another key word would be divided or shared equally among. Now, when I say that, it doesn't have to say that as exact words, okay? Divided or shared equally among. So that might say something like 3,048 divided equally among 24. Okay, now the symbols for all of these would be 3,048 divided by 24, or any of the other symbols we talked about a minute ago. Again, I'm probably going to use this division line or fraction line because you usually will see that more in algebra. Okay, so those are the key words so far for division. Okay. Now, let's, for a second, before we go back to actually dividing that big problem, I'd like you to take a moment and go to your workbook and do some very small problems that are in there right now so that we can get a taste for this division. Okay, let's look at these problems. Number 1 says 8 divided by 4 looks like that. Number 2 says 12 divided by 3, but it looks like this. One of the other ways to write it. Number 3 says 10 divided by 2. Number 4 says 5 divided by 1. I'm going to hang on to number 5 for a minute because it's not going to fit up here. Okay, so let's take a look at this. 8 divided by 4. Okay, 8 divided by 4 is 2. 12 divided by 3. Well, that's 4. 10 divided by 2 is 5 because 2 goes into 10 5 times. 3 goes into 12 4 times. 4 goes into 8 twice. 5 divided by 1 is 5. Now we can check this. What's really cool is the opposite of division is multiplication, so we can check this. I can check this by going 2 times 4 is 8. 2 times 4 is 8. I can check this by going 4 times 3 is 12. I can check this by going 5 times 2 is 10, which is another reason I like this version, because watch this. If I write it like this, 10 divided by 2 is 5, I know I just multiply those two, and I got the numerator, or the number on top. Okay? 5 divided by 1 is 5. I can check that. 5 times 1 is 5. So your quotient times your divisor has to give you your dividend. Okay? Let's look at, number 5. I forgot about number 5. Okay. I'm going to leave number 4 up there because I'm going to refer to it in a second. So let me put number 5 right next to number 4. Number 5 is 8 divided by 8. So we want to know how many times 8 goes in 8, and that's obviously 1. Now, let's look at this. This is telling me that if I have a number and I divide it by itself, I get 1. Well, we want to know is that always true. So if I have 7 divided by 7, will that be, it won't be 7. That would be wrong. So maybe 7 divided by 7, that would be 1. 6 divided by 6, that would be 1. So notice that this is true every single time. So that means that's going to be a property we're going to talk about in a second. Same thing here. Let's look at this. This says if I have a number and I divide by 1, it looks like I get that number back. Well, is that always the same? Is that always true? 7 divided by 1. How many times does 1 go into 7? Well, it takes 7 ones to make 7. Notice the check. 1 times 7 is 7. 1 times 6 is 6. 7 times 1 is 7. So I can see that these all check. So these are some properties we're going to talk about. Okay. So let's look at division properties of 1. Okay, the first one we want to talk about is the quotient of any number and 1 is that same number. So let's look, for example, a math example. 4 divided by 1 equals 4. The quotient of any number and 1 is that same number. Okay? In algebra, instead of using a number, I could use a letter for any real number. A divided by 1 would equal A. 1 times A is A. 1A is A. So that makes sense. So that's one of the properties. So that's this one right here. The other property is this one. When a number is divided by itself, I get the number 1. But there is one little thing you have to be careful of. Okay, we're going to talk about that in a second. 10 divided by 10 equals 1. A number divided by itself is 1. That works. I could check it. 1 times 10 is 10. But it does not work when you're talking about 0. Okay? Here's why it does not work when you're talking about 0. 0 divided by 0 is not equal to 1. Even though it checks 1 times 0 is 0, I could honestly put any number here and it would check. 4 times 0 is 0. Any number I want could go here and this would check. So this 0 divided by 0 is not 1. 0 divided by 0 is called indeterminate. We cannot determine the answer because I could put any number there and it would work. So it's got to be any non-zero number divided by itself will give you 1. So I could say this in algebra. For any non-zero real number, that's what I would have to say. For any non-zero real number A divided by A is 1. So it would have to be like that because it can't be 0, because 0 divided by 0 is not 1, because it could be any number you want it to be. Okay. In fact, let's look at dividing by 0 and dividing into 0. I hate that into. Sounds like a sneeze. Okay. Goes into. All right. Let's look at the following two problems. So find the quotient and check. I like to check because it makes sure we know if we're right or not. Okay, so let's do 0 divided by 20. And let's do 20 divided by 0. Okay. 0 divided by 20 is 0. I know that's hard to really understand because I have no things. I'm divided by 20 things. And you kind of can't grasp what that means tangibly. I can't really show you what that means, but I can show you that this works, and it's the only number that will work. 0 times 20 equals 0. That's a true statement because that checks. 0 times 20 equals 0. There's your check. So if 0's on the top in the numerator, that's called a numerator, your answer will be 0 as long as there's not a 0 on the bottom. Remember, you can't have 0 over 0. 20 divided by 0, let's talk about that. 20 divided by 0. Well, think about what the check means here. The check would mean that this number, whatever we put here, times 0 would have to be 20. Well, that's the hard part. There's no number that I can find times 0 that's going to give me 20. Therefore, this cannot be done. So this is called not indeterminate. Indeterminate was for 0 over 0 because there was more than one answer. This is undefined. We cannot define this. You cannot divide by 0, not ever. Some way you might want to remember this is when 0 is under, it's undefined. Undefined. All right, it's bad. Okay, I like to check better, to be honest, because that's more mathematical, but it works. You might remember it that way. So 20 divided by 0 is undefined. In fact, any number divided by 0 is undefined. Okay, so we see when zeros in the numerator are on top and you're dividing by a non-zero number, we get 0. But we cannot divide by 0. We showed you why, because there's no number times 0 that will give you 20. Okay, and we already showed you that 0 divided by 0 is undetermined. That's because there are many different answers for that, because any number we put here times 0 would be 0. So you're not going to come across this too often, but just so you know, this is the different situations. So let's just summarize really quickly, which is in your workbook, the rules for dividing by 0. Okay. Now, because we know this is true for all real numbers, we're going to use letters. I just used some numbers. Now we're going to use some letters. Okay. I'm going to use X, because we're going to start using X a little bit more. Okay. So the rules for dividing with 0. Let me write 0. Okay. Okay. First rule is this one that tells me that 0 divided by any non-zero number, remember this can't be 0, is going to give me 0. Again, I can check. 0 times whatever this is going to be 0. Okay? That's the first rule. The second rule is any non-zero number divided by 0 is going to be undefined. Because nothing times 0 is going to give me a number, or X. Okay? And the last and final thing is when I divide 0 by 0, that's undetermined. Because the truth of the matter is I can get infinite number of answers here, because anything times 0 is 0, which can't be true. The one great thing about math is there's not really any gray. There's got to be an answer. So that's called undetermined. So those are the 3 rules for dividing with 0. Now let's talk about divisibility. Okay, so a number is divisible by another number if the remainder is 0. Let me give you an example of that. Okay, so some of these examples are in your book. Okay, let's start with, I think the first example I want to show you is 8 divided by 4. 8 divided by 4. The second example is 12 divided by 2, 12 divided by 2, and 15 divided by 3. Well, 8 divided by 4 is exactly to no remainder. You might remember that we use R for the remainder. Remainder is 0. Okay, that tells me that 8 is divisible by 4 because it's 2 with a remainder of 0. Whenever the remainder is 0, that means that this number is divisible by this number. 12 divided by 2 is 6 with a remainder of 0. So that tells me that 12 is divisible by 2. 15 divided by 3 is 5 with the remainder of 0. So that tells me that 15 is divisible by 3. And I can do this all day. Okay? If there is something left over, we don't really call it a leftover, we call it a remainder. Okay? So let's take a look at how to check this stuff and what that means. Okay, so 8 divided by 4 is 2. So the check, remember, is 2 times 4 is 8. And here the check is 6 times 2 is 12. And here 5 times 3 is 15. So those are the checks. Let's make sure we write this down, how we check. Okay, let's notice what we did to check. We multiplied this number and this number. This number, it was called, remember, the quotient, because it's the answer. This number down here is what we're dividing by. Remember, that's called a divisor. And this number right here is called the dividend. Okay. So what you multiplied is you multiplied the quotient times the divisor. So the check is the quotient times the divisor. Now, if you have something that's divisible, that would be your answer, quotient times the divisor. But if you have a remainder, you'd have to add the remainder plus the remainder and that would give you the dividend. So let me write this a little smaller so we can fit it here. Quotient times the divisor plus the remainder equals the dividend. Okay, let me show you two examples. One right here, okay? So the quotient here, the quotient is 2. So we have 2 times the divisor, which is 4. Okay, let me move this up a little so you can see it's a multiplication sign. Plus the remainder is 0. Oops. It's supposed to equal a dividend, and the dividend is 8. Well, that's obviously true. 2 times 4 is 8, plus 0 is 8. What if we have a remainder? So let's just look at a quick example of if I have a remainder. Okay. Let's just do something really quick. 9 divided by 2. Well, 2 goes into 9 4 times. That gives me 8 with a remainder of 1. Okay? So 2 goes into 9 4 times. That gives me 8, remainder 1. Now, 9 is not divisible by 2, because if it was, there would not be a remainder. But I'm going to do the check. So the check is the quotient, okay, times, I'm just going to do this a little shorthand, the divisor, plus the remainder, if I spell it right, equals the dividend. Okay, so quotient is 4 times the divisor, which is 2, plus the remainder, which is 1. That's supposed to equal a dividend, which is 9. And here we go. 8 plus 1 equals 9. That's a pitiful 8. Okay? So that's how you get the check. The quotient times the divisor plus the remainder is the dividend. And that's the check for that. Again, that works every single time. Okay. Now let's talk about commutative and associative. Do you think division is commutative? Well, that means we could switch the order. Let's go back one more time to a simple question. 8 divided by 4 is 2. Will you get the same answer if you do 4 divided by 8? No, because 4 divided by 8, in fact, that's one of your great friends, the fractions, which we'll talk about later. 4 divided by 8 is not 2, okay? 8 does not go into 4 twice, okay? In fact, 8 doesn't go into 4 at all, okay? So you're going to have to get a decimal out of that or keep it as a reduced fraction later, and we'll see that in Chapter 4, or Mod 4. Okay, so division is not commutative. It is also not associative. Okay, to summarize this, and I know it says it in your workbook, talks about division being not being commutative or associative, but let's talk about this a little better. Division is not commutative nor associative, and I'm going to add neither is subtraction. So subtraction and division, and I should change this then to are not commutative nor associative. And then I'll put here addition and multiplication are both commutative. And remember why. Multiplication is repeated addition. And associative. Kind of important. Okay, you may want to learn this other method called short division. Short division, not everybody likes it, but it's a nice method if you're dividing by a single digit, like these problems, okay? We're going to do it together. If you don't like it, you do not have to learn it. This is the one thing I'm going to tell you, it's your choice. Here's how it works. You don't actually go down in the problem. You actually do it like this. I'm using a different color so you can see it. 5 goes into 6 once with a remainder of 1, and you put that 1 right there. And then 5 goes into 13 twice. That would be 10, and there's a remainder of 3. And then 5 goes into 38 7 times. 5 times 7 is 35. That leaves a remainder of 3. And then 5 goes into 35 7 times. So we get 1, 2, 7, 7. So that's the answer for that problem. That's short division. Okay? Let's try 2. 2 goes into 2 once. No remainder. 2 goes into 2 once. 2 cannot go into 1, so you put a 0 there, but now you got to carry that 1. Be careful. 2 goes into 12, 6. So your answer there is 1,106. And this last one, 7 into 2,520, or 2,520 divided by 7. Better way to say that. 7 doesn't go into 2, but 7 can go into 25 3 times. Put it over the 5. But there is 7 times 3 is 21, leaves a remainder of 4. 7 into 42 goes exactly 6 times, and all you have is a 0 here. Just bring it up. So that's 360. And that's short division, kind of simple. Okay, let me show you 2 more. Okay. So again, and again, if this doesn't make that much sense to you, you can either rewatch this video, or you can say, I don't want to do short division, and you can do all of this by long division, which we'll be doing in a second. Okay, so the next one is number 4, which is 18,036 divided by 9. Okay, so 9 goes into 18 twice, because it doesn't go into 1, so I have to use 18. No remainder. 9 does not go into 0, so you just put 0. 9 does not go into 3, so, but remember now to carry the 3. 9 goes into 36 4 times, so that's 2,004. You may not like this. It's okay if you don't. Okay? I'm not going to say that very often. It's okay if you don't. Okay, let's look at 5. 5 says 2,399 divided by 3. Okay, 3 does not go into 2, but 3 goes into 23 7 times. 7 times 3 is 21. There's your leftover of 2. 3 goes into 29 9 times, because 9 times 3 is 27. Understand, if you don't have your multiplication facts down, this is going to be hard. So there's a remainder of 2 again, and then again a 9, and that's 27, so there's a remainder of 2. So it's 799, remainder 2. So that's the answer for that question. Notice 18,036 is divisible by 9. 2,399 is not divisible by 3 because there's a remainder. Here, 2,520 is divisible by 7. That is short division. Now, I have to tell you, learning your multiplication facts is really, really, really important to be able to divide. However, there are some divisibility rules that will help us divide. So let me show you what those are. Okay. The first one is it's easy to tell if a number is divisible by 2. A number is divisible by 2 if the last digit is even. So let me show you. Well, for instance, this number wouldn't be divisible by 2 because the last number is not even. This number would be. Okay? But one of the examples in your workbook, because all these rules are in your workbook, is the number 23,768. You want to know if that's divisible by 2. We don't want to do the problem. I just want to explain to you that this is divisible by 2 because that last digit is even. This last digit is even, it's divisible by 2, so there'll be no remainder when you do this problem. Okay. Then you have the divisibility rule for 3. Okay. Now, there's an example in your book. We don't have to definitely look at the example in your book. We can look at any example. I'm going to look at this one in a minute because this one's not divisible by 3. But I can make up a number very quickly that is divisible by 3. Watch. I know you're going to be impressed. Okay. Okay, I know that's divisible by 3. Here's how I know that's divisible by 3. I know that's divisible by 3 because in order to be divisible by 3, you've got to take all the digits and add them up. 4 plus 5 plus 3 plus 1 plus 2. Those are the digits. If the sum that you get is divisible by 3, then the number is divisible by 3. So let's look at this sum. 4 plus 5 is 9, plus 3 is 12, plus 1 is 13, plus 2 is 15. That number is divisible by 3, which makes that whole number, that entire number, divisible by 3. So that's one way to do that. Then there's a divisibility rule for 4. Oh, let's do this. Before I go on, let's do this. I knew right before I started this problem that this number was going to have a remainder. Let me show you how I knew that. In my head, I know, I'm a genius. But in my head, I took these numbers and I added them. And what I noticed was this sum is not divisible by 3, because this is 18, 21, 23. This sum is 23. 23 is not divisible by 3, therefore the number was not going to be divisible by 3. So it's a really cool way to find out if the number is divisible by a specific number. There's a rule for 4. The rule for 4, and I'm going to use it in this problem here. I'm going to actually just use this one. The rule for 4 says if the last 2 digits make up a number that's divisible by 3, divisible by 4. If the last 2 digits make up a number that's divisible by 4, the entire number is divisible by 4. So the last 2 digits, you don't add them up. The last 2 digits make up the number 12. Since the number 12 is divisible by 4, that entire number is divisible by 4. So that's kind of cool. Then there's the number 5. How do you know if a number is divisible by 5? Well, that's really simple. I know if a number is divisible by 5 if it ends in a 5 or if it ends in a 0. That's how I know. So that's really simple. To tell if a number is divisible by 6, the number has to be divisible by both 2 and by 3. So, for instance, this problem we said was divisible by 3, but it's also divisible by 2 because the last digit is even. Okay? So therefore, that number is divisible by 6. And there are rules for a lot of different ones. 7, 8, 9, 10 is an easy one also. The last digit has to be a 0. So just practice some of the divisibility rules because there are examples with each one in your workbook. So that helps me divide other numbers. Okay, let's take a look at using a little logic when we do division. Okay. Let's say you have this multiplication. This multiple choice question, not multiplication. Let's say we have 16 and 512. So 512 divided by 16. And here are your choices. Choice A is 3. Choice B is 32. And choice C is 320. And we want to make sense of this. Well, how I would do this problem is I would probably look at my choices and realize that 16 times 3 is going to be a really small number. In fact, I would probably either round that to somewhere like 15, because I know 15 times 3 is 45. So that's definitely not going to be a viable choice. If I think about 32, I might do this. I might just round that, talking about rounding and estimating, to 15 and round that to 30. And I know 15 times 3 is 45. That's going to be 450. So I'm going to do a little rounding in my head. And I notice that that number is bigger than 15. This number is bigger than 30. This is going to be the answer, because this is going to be way too big. So that's how you can use a little logic to divide if you have something that's multiple choice. You don't have to actually do the problem. That's where that rounding and estimating comes in. Let's try one more. In fact, you try this one, and we'll come back and talk about it. So this is the next one. Okay, so let's see how you did on the second problem. Again, you really should just estimate this. So if I change this to 60 in my estimate, or rounding, and I take a look at this, 60 times 2 is 120. That's way far away. If I estimate this choice to be 30, that'll make it easier, 1800. That looks like that's definitely going to be the answer, because 30 is bigger than 27, and even though 60 is less than 63, it's not that much less. And this obviously will be too big. So again, my choice is B. So the correct answer is B, without doing any real division, just by using estimation rounding. Okay, now let's take a look at the big gun, okay, the regular long division. Think about the problem we did before. The problem that we did before said we owed $3,048 for your car, and you wanted to break that up into 2 years, which was 24 monthly payments. So let's take a look at this. 24 into 3,048. Now, I have to tell you, when I first started to teach long division, I would teach it and everybody was going with me, and then they'd go home and go, I forgot what step to do next. So in order to stop that, I have a little idea, okay? To divide long division is all you do. You divide, you multiply, you subtract, and you bring down the next number. Now, in order to memorize that, you can think of this. Ready? D for divide, dirty. M for multiply, monkeys. S for subtract, smell. B for bring down, bad. Dirty monkeys smell bad. I really don't know if they do, but I assume they do. It doesn't matter, but you probably would remember dirty monkeys smell bad. And I have to tell you, I really did make this up years ago, and I was on the internet, and I saw this. Dirty monkeys smell bad. I think somebody told them about this. But I had never seen it before. I made this up years and years and years ago. I mean, I'm a lot older than I look. Okay, so let's do this problem. Okay, so we got 24 into 3 does not go. So we're going to start. I like to start by doing this to remind me the steps. Dirty monkeys smell bad. Okay, so we're going to divide. 24 goes into 30 once. Okay, now, so we divided. Now we're going to multiply. So we're going to go 1 times 24 is 24. Now we're going to subtract. Okay, so 30 minus 24 is 6. Now we're going to bring down. So we bring down this number. And now we have to start over again. So we go back to dirty, or divide. So now we're going to divide again. 64 divided by 24. Well, 64 divided by 24, if you think about it, let's think about this for a second. 24 times 3 will be too big. So let's do 24 times 2, which is 48. And again, you might have to do some work on the side to divide. So we just multiplied, because 2 times 24 is 48. So we multiplied. Now we're going to subtract. So we subtract this. We're going to have to borrow. We get 16. 24. Oh, I forgot to bring down. See? Thank God I have this here. We have to bring down 168. So now we have to figure out how many times 24 goes into 168. So I'm going to round a little bit here just to see. I'm thinking it should be somewhere around 240 times 10. 24 times 10 is 240. It should be about half of that. I'm thinking maybe 5. So I'm going to do 24 times 5 here. See how close I am. That's 120. That's not big enough. 6 looks like it'll work. So let me try 24 times 6. I mean, you know, just trying stuff. That's 144. That'll do it. Oh, nope, 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 that won't do it. Sorry. 24 times 7 is going to hit it on the nose. Yep, there's your 168. So here's your 7. That's 168, and our remainder is 0. So the answer is, this car will cost you $127 a month. But it's dirty, monkey smell bad. Divide, multiply, subtract, bring down. You're going to have to go back through it. Okay? So let's try another one. And you may have to do some of this sidebar thing, but the important part of this is do it on the side. Don't put all the work together because it'll get so messy you won't know what you're doing. So let's try one more, and then we'll do some verbal problems. Don't try to get the blue top on the black pen. It doesn't fit. Okay, let's try another one. Okay, I'm going to take this off, this example, so we can start from scratch. Okay. All right, and our next example is written exactly this way. $4,908 divided by 67. That's division. It's divided by 67, by 67, by to 67. It goes on the outside. Looks like that. Want to do some long division? Again, I want to do some dirty monkeys. Dirty monkeys smell bad. Okay, we're going to divide. 67 does not go into 49, so we're going to have to go 67 into 490. Okay, so if I round this to 70, that'll go in exactly 7 times. So let's try 7. Okay, so we're dividing. So I'm trying to find out what this number is. So 9, 4, 42, 46, 469. That's going to be good. So there's my division step. Now, I've already multiplied because I tried to do it. I had to estimate it, and I get 469. Now I'm going to subtract. I have to borrow to subtract. So I get 1 here, I get 2. Now I'm going to bring this down. Let's not forget that. Now we have 218 here, so we have to divide again. Okay, so now we're going to go 67 into 218. If I round that to 70 in my head, I'm thinking that's going to go about 3 times because 70 times 3 is 210. So let's try that. 67 times 3 is 201. I'm not going to get another one. I can't go to 4. It'd be too high. So I'm going to do 3, and that's 201. That's the multiply step, which we really did right there by checking it. So I divided, I multiplied. Now I'm going to subtract. And here we get 17. So my answer is 73, remainder 17. Now, in your workbook it says to check this answer. Okay, we'll do that. To check this answer, here's what we're going to have to do. We're going to have to check. We're going to have to multiply your quotient times your divisor and add the remainder. So we're going to have to do 73 times 67 plus 17. And we should get, if we've done this right, 4,908. So let's hope for that. All right, I'm going to erase this so we have space to write. All right, and we're going to do the check. Here we go. 73 times 67. Okay, so 7 times 3 is 21. Carry to 2. 7 times 7 is 49, plus 2 is 51. Placeholder, 6 times 3 is 18. Carry to 1. 6 times 7 is 42, plus 1, 43. Okay, now we add 1984. So that's 73 times 67, and now we're going to add 17. And let's hope we're lucky here. Okay, that's 8, 10, carry to 1, 9, 4,908. So there it is. It all checks out. So that's long division. Dirty monkeys smell bad. Okay, now let's take some of what we learned and apply it to some verbal problems, right? Because the story problems is really where it's at. That's what we're going to have most of. So let's look at this first equation that talks about the Spring Hill Public Library. Okay, the Spring Hill Public Library has 6,045 books. All right. I really didn't count them, but who knows. 6,045 books, and we know that each shelf holds 65 books. And we want to know how many shelves you need. Okay, well, here's what you got to think about. You have these shelves, and they all hold 65 books. So you have 65 here, 65 here, 65 here. And you want to know how many shelves you need. Well, that means we're dividing equally among these shelves. Okay, so that's how we know it's division. We're separating into equal sets, or equal divisions. Okay, so we're going to divide this to figure out how many we need. Guess what? Dirty monkeys smell bad. I feel them smelling bad. Okay. Dirty monkeys smell bad. Okay, so we need 604 because 65 does not go into 60. Okay, let's try, I'm thinking 8 times. 8 times 5 is 40, carry the 4. 8 times 6 is 48, plus 4 is 52. No, we can definitely get another one in there. So 65, by the way, I was going to do 9. I should have did 9. Okay, 65 times 9. 9 times 5 is 45. 9 times 6 is 54, plus 4 is 58. 585. So there's my division. Of course, that's also my multiplication because I know 9 times 65 is 585. Okay? So now I did my division, I did the multiplication, now I have to subtract. Okay, now here's the deal. Remember, I can't borrow from that 0. I'm going to box it in, and now I'm borrowing from 60, which makes this, and it's a little hard to see, 59. There's my 1. 14 minus 5 is 9. 9 minus 8 is 1. So we get 19. Okay, so now that's my subtract. Now I have to bring down. So I'm going to bring down. I bring down the 5. I'm thinking that's about 3. Let's try 3. 195. Oh, that would be a winner. Okay, so there's your 195. Remainder 0. We're going to have to buy more shelves or not get any more books because we need 93 shelves for those books. 93 shelves. Okay. So that's Dirty Monkey Smell Bad, long division. Again, we're breaking this up into equal quantities. That's how I know it was division. Shared equally among. Okay? So that's the Spring Hill question. There's one more problem. Oh, sorry, there's 2 more. Okay, let's go to this next problem. This next problem says that Mike earns $18,720. All right. $18,720. And we want to know what is his monthly salary. Well, his monthly salary, there are 12 months in a year. Each month he's going to get paid the same salary. It doesn't tell me otherwise, so I have to assume that. So it's shared equally among those months, so that tells me it's division. So let's do some more long division. Okay. Dirty monkeys smell bad. Okay, here we go. We're going to divide. 12 into 18 goes once. Now we're going to multiply. 1 times 12 is 12. Okay? Now we're going to subtract. 18 minus 12 is 6. Now we're going to bring down. Okay. Now we're going to divide again. I can do this one. 12 times 5 is 60. So that's 5. We multiply, we get 60. So there's division and a multiplication step. Now we have to subtract. 67 minus 60 is 7. Now we have to bring down. $12 into 72 goes exactly 6 times. 6 times 12 is 72. Nothing left. If we bring down the 0, you can bring it down. If you bring down that 0, you just have to put it up here anyway. So you can either bring it down or just put that 0 up there. It doesn't matter. You might want to bring it down just so you're following the steps all the way through. So each month, Mike makes $1,560. Okay. I'm hoping that's after tax. Okay, let's do B. We want to know his weekly salary. So there's 52 weeks in a year. So now we're dividing this number by 52. Okay. All right, so be very careful about taking his monthly salary and doing something with that answer, because not every month has the same amount of weeks in it. Some months have more than 4 weeks in it. Okay, So here we go. Divide by 52. Dirty monkeys smell bad. Okay. 18 divided by 52, can't do it, so I have to put 52 into 187. 52 into 187 is going to be 3. That's 156. So we've divided, we've multiplied, now we have to subtract. 7 minus 6 is 1, 8 minus 5 is 3. Okay, so we've subtracted. Now we have to bring down. By the end of this, you really start hating the monkey, but it's okay. Okay, so now we have to put 52 into 312, or 312 divided by 52. I'm thinking around 6. Okay. Oh, 6. That's a winner. Okay, so there's 6. So that's the division step. We already know that's 312 when we multiply. We subtract, we get 0. Let's bring down, just to keep the flow going. And then 52 into 0 is 0. So it's 360 per week. So Mike makes 360 per week. Okay. Okay, let's do part C of this problem. Part C of this problem says, okay, if his net pay, and let's explain net pay, because this used to confuse me, net versus gross. I always thought that gross was after taxes because that's when it's gross. But it's really not like that, okay? Net is after taxes. So this is after taxes, his net pay. Okay, it really should be the other way. I need to talk to the government about that. But anyway, if his net pay per month is $1,148, $1,148, and he pays half of that on rent. Half on rent. Here's the question. The question says, how much does he spend on rent for the entire year? So that's the question. Okay, so if he spends half of that on rent, we need to find out how much he spends on rent. Well, that means I'm going to take 1,148 and divide it by 2. Yes, I'm going to use short division. You do not have to. I'm done with the dirty monkey. I'm using short division. Okay, so 2 does not go into 1, but 2 goes into 11 5 times. That's 10 with a remainder of 1. Oh, now I'm starting to try to write with the cap. That's really not good. Okay, 2 goes into 14 7 times. 2 goes into 8 4 times. So he spends $574 on rent for the month. But now we want to know how much he spends on rent for the year. So we have to take that monthly payment and multiply it by 12. So sorry, I don't have a trick for that. Okay, 2 times 4 is 8. Well, there is something you could do, but that would make it hard. Okay, 2 times 7 is 14, carry to 1. 2 times 5 is 10, plus 1 is 11. And then, of course, we'll get the little placeholder going on. 1 times 4 is 4. 1 times 7 is 7. 1 times 5 is 5. Okay, so now we're going to add this up. 8, 8, 8, 6. $6,888 is how much he spends the entire year. Okay, that takes care of Mike. Okay, one last problem, okay, to end this up. Okay, you have 7 girls, and I think they played a lottery, okay, and they win. They don't win a whole mess of money, but, okay, they win $3,000. 7 girls winning $3,000. Win $3,000. So 7 girls. That's a really bad G. That's not any better. Okay, 7 girls win $3,000, but they want to divide the money. There's a remainder. So what they do is they draw straws to see who gets the extra money. Okay, so we want to know how much does the girl who wins actually gets. So we got to first divide 3,000. Okay, I'm going to show you, because I've been doing this short division, that you can do dirty monkey smell bad even with 1-digit numbers. I'm going to do that one more time just to get used to dirty monkeys. Here we go. 7 does not go into 3, but 7 goes into 30. So here's my division. 7 goes into 30 4 times. Okay, now I multiply. 4 times 7 is 28. Okay? Now I have to subtract. I get 2. Now I have to bring down. I get 0. Now I have to do 7 into 20. Well, 7 goes into 20 twice. So that's my division step. Now I multiply. 2 times 7 is 14. And now I have to subtract. I get 6. I have to bring down. 7 goes into 60. Oh, I kept forgetting to cross him out, bring down. 7 goes into 60 8 times. That gives me 56. So I just divided again. I multiplied again. Now I'm going to subtract again. That gives me a remainder of 4. So there's a remainder of $4. You know, for me, I wouldn't have had to deal with all that division if somebody just would have said, here's the money. Okay, but okay, we get $4. So each person gets $428, but the winning person who got the extra money gets $428 plus 4, or $432. So that's how much the winner gets. Okay? And that's the end of division. Don't forget Dirty Monkey Smell Bad. If you like short division, use that. And the next lesson we're going to do is exponents and order of operations.